calculus. Okay, calculus. Okay, so this is gonna be on the topic of motion topic. Okay, so let's familiarize the motion formulas. Okay, wait. Okay, so before anything else, so let's review. Let's reflect our lessons from physics, right? Physics. Here, physics. Okay, physics. Okay, number one. Uh, the rate of change of speed. Okay, what's that all about? The rate of change of speed. Okay, let's recall. What's this quantity all about? The rate of change of speed. Diba? Mm-hmm. Sabi mo siya mga palangga. So this is acceleration. Okay. Acceleration in scalar form. Scalar form, meaning we are not considering the direction. Number two, the rate of change of velocity. Okay, what's that all about? The rate of change of velocity. So this is obviously acceleration in vector quantity. Okay, you get the point? So later we will express this in symbolic or chemical formula in vector quantity. So meaning to say, considering both the magnitude and the direction, okay? In acceleration in scalar form, only the magnitude. Okay, there's no direction. Okay, vector form. Okay, number three, the rate of change of the distance. What's of this? The rate of change of the distance. Okay, so this is the speed. Okay, speed. We don't have to put in scalar form because speed is obviously in scalar form without considering the direction, only the magnitude. The car moves 10 meters per second. Okay, that's speed. There's no direction. Okay, we don't point out the destination. Okay, things like that. Okay, number four. Okay, the rate of change of displacement. Okay, what's this all about? The rate of change of displacement. So this is displacement. So this is the velocity. So the velocity now is the scalar, no, it's the vector quantity, both the direction and the magnitude. Junjun travels 20 kilometers per hour to the south. Junjun travels 100 the left side or in the runabout. So that is velocity. But if you don't mention the direction, then that is only speed. This is to be technical only, because generally speaking, we can use also speed even though we are not mentioning the direction for the typical understanding. But to be highly technical, so with science knowledge, then we need to apply this grammar accuracy in physics, okay? Things like that. But this is not so important, but to be highly technical for the purpose of the examination, okay? Things like that, right? But it's wrong also to say we need to correct, okay? Actually, it's wrong, okay? But since the people are practicing that, then nobody dares to correct, right? Because they think that that is only minor to consider. So what's the purpose of our education if that is the case? Why we go to school? Why we went to school if we will not apply the knowledge and the lessons taught by our physics teachers, right? Okay, that's you will be the one to answer that. Okay, so going back to physics, the rate of change of speed acceleration, okay, in scalar form. Okay, so what do you mean by acceleration in scalar form? You need to say the ball is accelerating regardless if it is downward or if it is in horizontal position or in diagonal or whatsoever or in a projectile manner. You get the point? No, it will create a projectile. So the ball is accelerating in that manner also, right? If you throw the ball, when you throw the ball, of course the ball is accelerating. Get the point? Oo. So since we don't specify the direction, that is only the acceleration in scalar form, the rate of change of speed. Okay. So number two, the rate of change of velocity, the scalar form in vector quantities. For example, if I throw the baseball to the wall of the house, oh, there's direction. I need to throw the ball to the catcher. This is acceleration in vector form, like that. Okay, there's direction and magnitude. Number three, the rate of change of distance, and this is only speed. I discussed a while ago, right? And then the rate of change of displacement velocity if you consider the direction. Okay, for example, the typhoon is from 20 kilometer per hour west of east. Okay, so that is the velocity. So actually, if you listen the newscaster, okay, in the TV, they are actually wrong grammar. Okay, because they're saying the wind is going like that, but they use still the speed. In fact, that's already velocity, when velocity, because they're describing the direction. Okay? Since they are not professionals, they are not science professionals, they are mass communication graduates, so it could be accepted, right? Okay, but once the science professionals will say that, maybe that's an issue. You got the point now for science teachers, like particularly the physics teachers. Okay, so very technical in the knowledge, no? Things like that. That's still minor, but obviously it doesn't mean that that is minor. We don't have to correct. It doesn't mean that that is the whole world is practicing that we don't have to correct. Maybe the whole world is wrong and you'll be the one is correct. You get the point? Things like that. Okay. Any question for this? 1, 2, 3, 4. Now we're gonna navigate this to integral and differential calculus. Actually, differential and integral calculus, the prerequisites are physics also. If you notice that, physics algebra. Okay. And I think the until trigonometry, that no, analytic geometry. So those are the prerequisites because it is of math, the physics. Okay, things like that. Particularly in integral and differential. Okay, now when you speak about the rate, capital S, let's say like that, S prime is equal to ds over dt. So meaning to say, this is the rate of change of the motion. Get the point? So ds dt. Ganon. Okay. Sometimes they denoted that as x also, x in motion. Okay, or the possession, no? So it's better to say possession. Okay. Possessioning. Okay, get the point? So actually, motion is possession is part of a motion. You get the point? X because of possession. So it's gonna x prime dx dt, like that, no? Okay, things like that. This is the rate of change. Okay. Then in integral, it's more about on the areas and the volumes and the curves generated on the axis, like that, no? So you can sense if it is integral or differential. Okay. If we touch motion, it could be both from integral and differential. Okay. Now let's go to integral calculus. Okay. So in integral calculus, so if the lesson will be like this, it's very good, right? Right? Because in our college education, in our engineering, if we study differential, all will be differential. If we study integral, all will be integral. We will never touch the differential. We will never touch the integral. So I hope this will be no practice nowadays. No, that we need to what do you call this one? We need to articulate. No, we need to link all topics. No, in math. It's not only limited in this integral only. So it's not allowed to touch on differential. It's not allowed to touch in analytic. Okay, but I know that we don't touch, but if the time needs, no, in order for us to understand clearly, then we need to incorporate and we need to attach if it is really necessary to link that for our understanding with particular lesson. Okay? So you get the point. So it's not like that calculus na jud, okay? Algebra, specific. So that's why the students and the examiners in the future will be confused. Because they do believe that differential is only differential, integral is only integral, but at the end of the day, all mathematics will be blended into one concept. Okay? Things like they are really interlinked with each other, or they are really interconnected or intertwined with each other. Okay? So, now, integral calculus. Okay, mga palangga. So we say integral calculus. So what is our action verb here? The action verb will be integrating and the process will be integration. Okay? And then the noun that we'll be able to understand are those integrals and then or the reverse of the derivative, which is antiderivative. Okay, got the point? If integral, antiderivative. If differential, derivative, like that. Okay? That's very clear, right? So the action verb of differential is differentiating. Okay? And then the process is differentiation. Okay? And then the form is differentials or derivative. Again, integral calculus, the form is integrals. I think that is integral from 1 to 17 based on my memorization. But I don't think so if it's correct now, huh? Okay, get the I-17. I want to I-17. Okay? So what is the very basic example? I need to think of a very basic example of an integral. So let's say, ano lang, so integral 1 lang, no? So it's easy to remember. Okay, integral 1, or form 1, we have the integral of ex dx is equals to ax plus c. So this is integral 1. Right? Things like that. So this integral would mean also antiderivative. You get the point? We will say the antiderivative of ex dx is equals to x plus c, or the integral of ax dx equals to x plus c. Now, if we have also differential calculus, let's say katong exponent niya, no, sa let's say xn dx dt, o diba? O sabi na siya. Okay, so this is, or the x, so x n minus 1 over, what is it over, no, sorry, x minus 1, and then you have to multiply that here, no? Okay, so so if I have x2, it will become x2 minus 1, so therefore 2 times x, 2 minus 1 is 1, parang ganon. So you need to subtract the exponent in differentiation. But in integral, you have to add the exponent over the total exponent. Okay? Things like that. So it's the reverse, no? The reverse of the derivative is the antiderivative. Okay? Things like that. So we go now to the motion because motion is our topic, right? Okay. So if I will say, the rate of change of velocity. Okay, so we're gonna express that integral calculus as so the function of t is equals to the antiderivative or the integral of acceleration function of t. Pinagano talaga function of t. Things like that. No, on kakaloka. dt plus c. Okay, ang arte ng teacher pag gano'n mag-discuss v function of t integral of a function of t dt plus c. Kaloka. Okay? Things like that. So this is our the rate of change of velocity, and then the acceleration is involved in it here, no? Okay. So the second version, we talks about the possession. Kanang possession, guys, is all about the distance also. Okay? Don't be confused for that. Okay? Because it will take the distance. For example, the initial distance to the final distance, it will take the possession of an object. Okay, initial possession, then second possession. So it covers a specific distance, right? So that's why they are tantamount, or they are parallel with each other when we mean of distance and possession. You get the point? Any questions so far? But more on the concept of the possession is more on the displacement, but it would mean the same on in the context of the variable ba, okay, things like that, but only the concept will change a little bit, okay, but it would mean the same, okay. So we have here the possession, no? So we have here x, we use x instead of s, right? X function of t is equal to the integral. Okay, so how can you do this? The integral of v function of t dt plus c. When you add c, what this all about? See, when you add constant in a particular integral, what is the type of the integral that we have? So this is indefinite integral. If you see the capital C, that would mean constant. This means that indefinite integral or indefinite antiderivative, but it's usually called as the indefinite integral. If there's no C here, that is a definite integral. So that's very easy, right? If there's C, indefinite integral. If there's no C, definite integral. Okay, that's very clear. Okay, now if you try to, this is our integral IC, no? Integral calculus. Going toward DC, no? DC. Washington, DC is the capital of United States of America. The capital city of America is Washington, DC, right? Okay, so DC. So we have here sa velocity na punta, no? So the rate of change of velocity is the acceleration. So, okay, so acceleration function of t is equals to the v prime t. So this means this is the dv dt. Okay, the derivative of the velocity over the time, the derivative of the velocity over the derivative of the time. So if you don't want that, so you have also v prime t. It would be the same because the v prime is the first differentiation of the particular function. Okay, if two, the second differentiation. Diba? Things like that. This is the version of differential calculus equivalent to this. So the reverse, right? See, as you can see, the reverse. But the only difference is that we don't add C in differential calculus. Okay? Things like that. Now we go to the rate of change of the possession or the rate of change of the displacement. Okay, so it's gonna be like the v function of t is equals to the okay, x prime t, or this dx dt. Okay, so given a rate of change, always remember in differential calculus there always a rate of change, meaning to say there's a time in the denominator. An integral calculus, there's no denominator in it. Look at the form of the integral calculus. There's no denominator in that. But if you talk about, if you see or if you visualize differential calculus, there's a time in the denominator. Okay? And that's very clear difference also. Okay. Now we're gonna give you now sample problems. Okay? For this. So we're gonna create our own sample problems because in this manner it's not so difficult. You got the point? Okay, so motion, no? So let's think of a easy problem lang muna. Okay, so the object moves, for example, okay, the object moves, okay, the object moves at an acceleration function of t, okay, equal to, let's say, kaloka. Okay, let's say 16t minus, let's say 6, no? Pag sure, oy? Okay, yes. Oo. Let's say lang, okay? 16t minus 6, okay? At time 1 second with a velocity of, let's say, 10. How can we express it in simple? At a velocity of 10 at a time 1, okay? So, okay, this is v function of t, so this is v1 is equals to 10. Okay. And then at distance of x, no, at the time of 2. So x2 is equals, I think, let's try 17, no? Okay. Sige, let's try 17 siya. Okay, 17. Now, in this, guys, if you see the problem is always talking about the object moves, the particle moves, like that, no? We don't really be bothered on the unit of measurement. Okay, this is hypothetical. For example, electrons move with a function of 80 is equal to 20, like that. So you don't have to be worried with a unit of measurement. But once it is a macro perspective concept, like for example, the boat is moving. So it's impossible that the boat is moving in the sea without a specific velocity or in a nautical miles per hour, right? That's the unit of the velocity or the speed. If we try to navigate in the sea water or the sea, right? Nautical miles per hour. Okay. Things like, or the car moves, blah, 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 so on. So there must be always a unit of measurement. Since this is a particle, an object, so this is really an abstract thing. This is not a concrete because you cannot see what object I am trying to specify here. Okay? It's just like saying a particle, okay? And we don't know what's the particle all about. And then it's very also obvious that this particle will travel in a very minute and a very less speed and acceleration. That's why the unit of measurement also, it's not an issue, okay? It's negligible. You get the point? Just like saying that 1 atmosphere is equals to 1.013 bar. So in engineering calculation, we need to disregard the 0.013 because it doesn't have a bearing in our calculations, partially if point something only is the difference. You get the point? So actually, 1 atmosphere is not equal exactly to 1 bar. That is 1.013 bar. Okay, since it doesn't have an effect in most occasions, that's why 0.013 dropped off, no, by mathematicians. Okay, it become 1 also. 1 atmosphere is equals to 1 bar. Okay, but if you try to be technical, it's not 1 bar. It's 1.013 bar. Okay, hope it's clear. Okay, so here the object moves at 80. Okay, now so calculate things like this. Calculate the rate of change of the velocity, rate of change of the displacement xt for this. Okay, things like that. So how can we do this? Okay. So by using the formulas I presented a while ago, so we have the acceleration, no, function of t, or a function of t. Okay, so we're gonna say a function of t is equals to the integral of v function of t dt plus c. Okay, things like that. And then we have the function of 16t minus 6 in our 80, right? Here, tama ba na siya? It's the reverse. I'm using the differential. Okay, things like that. Sorry, guys. I love differential. No, I'm not loving differential because in fact, in my college days, my integral calculus is higher than my differential, my grade. Okay, because I had this instructor, very old, like a 70 plus instructor, that very old man and very genius. I think that he was the top notcher also in the chemical engineer board examination. I think Mr. Sigura of CIT, like that. And when he tried to explain, it's so difficult. Okay, like that. So I cannot understand. Get the point. That's why I keep on going to the library to just to rework what this instructor taught us, because I cannot really understand right away. Okay, I'm struggling with my differential calculus because actually this said differential is a lot easier than integral. But why my integral calculus is higher than with my differential calculus? Because it has to do something with the teachers. Teachers matters in the grades. You know this. Okay, everywhere you go, teachers matters in achieving our grades. Because if we have teachers that doesn't know or doesn't know how to elaborate more, doesn't know how to discuss with emphasis and clarity, then problem also for the students. We will be struggling. Okay, but if there are teachers also who are very active in elaborating the concepts, the effective techniques, no? Then the students also can really achieve the techniques well, okay, compared to those teachers that very fast in discussion, like that, and the students cannot understand and cry after the class. Actually, they are complaining, but it's not healthy to complain because before we think that teachers and instructors are our superiors. It looks like we don't have the power to keep on arguing with them because of the concept that they are our superiors. So we play a very great respect to our instructors. Have you fight your instructors before? Now tell me. It's human nature that we need to respect them, right? So the best way to avoid arguments, to avoid any conflicts or whatever, then we need to do by ourselves to study well. Okay, so there's no other choice. Maybe we felt also that we'll be not entertained by them because we feel that we are small, they are big, things like this, right? Okay, so normally, no, as a students and they are our instructors, there's a gap. Okay, we cannot really open directly to them unless siguro if the teachers, unless if the teachers are young, we have an close range to our age, then we can talk easily like a young instructors ba. You get the point? Or for example, if your instructors are 25 years old and you are 22, like that. So due to the age, close age gap, so it's easy to approach. But if those instructors are very old, problem also, right? Though not all, but most of the times. Okay? That's why we keep that by ourselves. Then we need to ask our classmates or we need to ask the senior students, no? Who already passed that subjects also. Okay? Or we can do it by ourselves na lang talaga. You got that point in that concept, in that manner. Okay, now, here, so the v function of t is equal to the integral of a function of t dt plus c. Okay, so this is our a function of t, right? So this is, we need to substitute that here. So here, so you love this topic because it's more on direct substitution, right? Okay, so a function of t, this is it, right? So 16t minus 6 dt plus c. Oh, so integral. Okay, so the difference also with the integral, guys, because we don't deal with the limits, lower limits and the upper limits. But the integral, no such like that. Okay, based on my memory recall. Does we apply limits in integral? Now tell me. In our ideas, okay? Meaning in our stock knowledge, do we apply limits in integrals or integration? But I'm pretty sure it's in the maxima and minima, right? Topic in differential calculus. I don't think so in integral, Okay, get the point? I don't remember. Maybe I'm just sleeping at the time. Okay? Things like that. So let's integrate now. Okay, now v function of t. So we are given also here the v1 is equals to 10. So what this all about if we have the 1 here? So this is also the time is equal to 1. Okay? Things like that. The time is equal to 1. Okay. So therefore, we can say here that, okay, that v1 is equals to 16 t2 over 2. Why t2 over 2? Because t1 plus 1 over 1 plus 1 sa denominator. Okay, minus 6t. So, why 6 dt, mga palangga, will be equal to 6t? By explanation. Why the derivative of 6 dt, no, the antiderivative of 6 dt is 6t. Why? Diba? Okay, because of the rule number 1, integral 1. Oh, diba? Integral of ex dt is equals to ex plus c. Oh. Let a is equals to 6, right? Oh, napagamang ganon, no? Diba? So let your dt is equals to x. Okay, therefore 6x, no? 6x. O, diba? So, the differential of 6x is 6. Tama ba? Okay, get the point? Oo. So, the integral is 6x. Because this would mean x raised to the power 0. And then this will become 6 times 1. You get the point? Oo. Things like that. So, this is 6. Okay, get the point, no? Okay, 1 man siya. And then the integral man siya, so 6t, no? Parang ganon, over 1. Okay? Things like that. Ano 6t ba? Okay, 6 dt. Okay? Things like that. Diba? Ano naman siya? 6t raised to the power 0. Diba? So 1. So 1 times 6 is 6. Okay, therefore 6t ang atong integral. Get the point? No? 6 dt, atong integral 6t. Atong differential 6 lang siya. No? Differential of a constant, no? Okay, differential of a constant with a variable. So, 6 na lang siya. Kaya ano naman siya? 6t1 minus 1. So, 6, 0. t to the 0 is 1 man siya. So, 6 times 1 is equals to 6. You get the point sa differentiation. Sa ito pa, okay, the differential of 60 is 6. So, the reverse is 60. So, that's why 60. Okay? You get the point? Things like that. So, 60 plus c. Okay, now, we have one unknown t. Since our t here is 1. See? 1. So we need to substitute 1, no? Okay. So V1. So what is the value of V1? So 10. 10 is equal to, then this one, 60 divided by 2, 8. T raised to the power 2. Okay. Then 60 plus C. At T is equals to 1 substitute. Okay. 10 is equals to 8 times 1 raised to the power 2 minus 6 times 1 plus C. Then it is become 1 times 1, 1 times 8. 6 times 1, negative 6 plus C is equals to 10. So therefore, 8 minus 6 mga palangga, 2. So 10 minus 2. 10 minus 2. Okay, positive, then transpose. So 10 minus 2, then C is equals to 8. Now copy this C in which you have the equation that contains C. So, di ba? Dara. You got the point? Kani siya. C. But you don't copy the values of 10, but instead put the function Vt. Okay? So, this is very clear. Again, when you compute for the C, substitute that to the equation above in which it contains C. So, where? Diba? Kani. Check. And then, you will remove the 10. Instead of 10, this is also the V function of T. Okay? Because that is why you are trying to look for to be used in getting the X function of T. You get the point? Things like that, no? So, atong Vt karon, Vt is equal to 8t squared minus 6t plus 8. So this is the velocity function of t. Okay, get the point? Get the point. But if the problem will say also, what is the velocity at 4 seconds? You'll substitute the 4 here, and this will become now your velocity. So be technical, ha? If I will say, what is the velocity if the time is equals to 4? I will never say anymore, what is the velocity function of t? If I will say velocity function of t vt, there is still t in that in which you don't substitute the time yet. Okay, so I'm just introducing maybe in the examination or examination, it will be like this also, and the value of t will be given in the final round, and you're gonna compute for the v. Okay, get that point? Because there's still t, see? Obviously, here. So, most probably the question will say like this, no? The object moves at a function of t is equals to 16t minus 6 with a v function of time 1, because 1. If it will not mention that is second, no? By default, ha? Yung ang mga differentiation, mathematics, if that's not mentioned, that is second. You get the point. Why? Because second is a metric unit of time, a metric system. Meter per second, like that. Okay, get the point. Dili ang hour, ha? You get the point? O second jud siya. Okay? Tell me, if not mentioned, second by default. Okay? Things like that. So, V1 is 10. So, what is the velocity at time is equals to 4? Ilad. So, 4, substitute 4 here, and you can get the velocity. Again, velocity function of t, it's not the same as velocity alone. Okay? It's very clear. Because when we say velocity of function t, okay, it would be as is if there's no given another time, or it would change to the velocity if there is given time after that in the question. In this case, there's no time given that here. That's why may mo ko velocity function of t. Stop here already. Ganun. Ako lang articulated and differentiated, no? Things like that. Now, since we are computing for the xt, what is the formula? Okay, the formula of xt, so it's going to be x function of t, differential, integral, integral of v function of t dt plus c. Now, you have now the vt here, okay? Substitute, no? Here, okay? So, xt. So, what is the value of your t? Oh, here. Xt. Gamit ka na siya mga function na. If you know the function theory in math, you can easily detect what it means, ha? You get the point? Or don't forget the previous lessons in algebra. Function theory. You get the point? Or the number theory. Okay? So if you say x function of 2 is equal to 17, meaning that t is equals to 2. Put here, x2 is equals to kaning v. So let's put that here. The function of t man siya. Okay, so 8t squared minus 6t plus 8. Then dt plus c. Okay, ganun. You get the point. Now, what is the value of your x function of 2? 17. 17 here. Substitute. Okay, 17. Okay. Now, integrate this whole thing. Okay. So, 8t to the 2 is 8t to the 3 over 3. Tama ba? Yes. 8t3 over 3. And then ang 60, 62 over 2. 62 over 2. And then plus 80 plus c. Compute for the c. How to compute for the c? We still have the t. Of course, the t here is 2. Okay, so 8 times 2 raised to the power 3. Substitute lang, no? Minus 6 times 2 raised to the power 2 over 2 plus 8 times 2. No, okay, ganun siya. 17 man na siya. So, 17. Compute na rin ka sa C. Okay, 2 raised to the power 3. 8. 8 times 8, 64. 64 divided by 3, mga palagingging. 0. Something, no? Char. Okay, na yung mga kida-kida. Let's say, we don't need to deal fraction here, guys, ha? In motion. Okay? So, it's not good to deal with fractions. Okay? Always numbers, no? Digits, number, point something, or whole numbers. Okay? So, this is, let's say, 3, 9, 10. Oh my gosh! This is non-terminating repeating number. Okay, this one. Irrational, right? Okay, 21.33. Okay, so 17 is equals to 21.33, mga palangga. Then minus 2 times 2, 4, 4 times 6, 24, 24 divided by 2, 12. Oh, dito na. Plus 16 plus C. Oh, so let's use calculator because there's something point something. Okay, are you still alive, my viewers? Okay. Oh, thank you so much for watching. Oh, I love it. Okay. Thank you so much for my viewers. You are my fellow mathematics teachers, right? Okay, thank you so much for the interests in math. Okay. Wow. Okay, hello, sir. Thank you so much for watching. Okay. They said I am a real teacher. Okay, things like that. Oh, I'm just joking, huh? That's according to their comments. Okay, so we have here 21.33 minus 12. Okay, so minus 12 plus 16 is equals to 25.33. Okay, 25.33 plus C is equals to 17. C is equals to 17 minus 25.33. We have a negative C. We have a negative constant here, no? Things like that. Okay. 17 minus 25.33 is equal to negative 8.33. Okay. So why we have negative 8.33? Because negative, guys, negative or positive is still an integer. So it's still considered as a constant by theory. Okay? So it doesn't matter. Don't always interpret that constant is always positive, because a constant concept, it is negative and positive, you know, positive integer and negative integer. Okay, that's constant. Okay, so C, negative 0.833. So let's substitute with C in which there's a C in there. Asaman tadapita mo lugar, chari. Okay, so asaman, dari area. Are, can I see, no? So, okay, so substitute na to si C. Let's substitute that here. Sorry for my viewers that cannot understand Bisaya. Okay, but because I mix Bisaya once in a while. Okay, things like that. Sorry, I am not a native English speaker nor a UK native speaker. Okay. I'm a Filipino English speaker. Okay, so we have here 17. So since 17 a while ago, so okay, so we need to go back to xt. This is xt before it. I'm just erasing that one. Okay, let's see, that 17. Okay, so x function of t. Okay, so it's equal to. So go back here. So it will become 1/8 over 3t cubed. 6 divided by 2, 3t squared, then plus 8t minus 8.33. Now, take a look. There is a fraction, right? Okay, get the point? So just leave that as it is. Okay? Because the moment you will divide this, it will become point something. So that would be okay. And to be sure, make it decimal point. Because we cannot divide this whole thing by 3 because you also put 3 here. So it missed the concept of x function of t. So that's why it's not good to simplify, okay, in this manner, no? Because you are used about simplification, then here it's not allowed, okay? Because the more you simplify this without denominator, there's a 3 here beside the x function t. And that is not allowed in motion problem, okay? 2.67. So this is x function of t is equal to 2.67t cubed, okay, minus 3t squared plus 8t minus 8.33. So this is the x function of t. In this topic, guys, you don't need to factor it out, You get the point, and you need to solve for the function of t. You equate x to t is equal to 0. No need. Okay, get the point? Things like that. Okay, unless it will ask for the value of time. But it will change the problem already, no? Okay? Or you will say at a minimum or a maximum, that is the theory of maxima and minima, no? In the theory of maxima and minima, you need to differentiate that in a first order differentiation, let that equal to 0 and solve the critical points. And you need to solve for the roots of t. So you can compute for the t. But in here, no need. Okay, you get the point? So for example, I will say, the object moves at a function of t is equals to 16t minus 6 at x2 is equals to 17. What is the time minimum of the distance function of t? Klaro kay minimum. So we need to say minimization, maximization, maxima, minima. So this one, you will try to differentiate this. Yeah, you need to equal this to 0. You get the point? So because in here, okay, we can factor chuvas here, no? And somewhere along the way, you can get also the quadratic formula or quadratic equation. See? 3t squared plus 8t minus 8.3t. There's a parabola thing here. You get the point? Things like that. Okay, but up to now, for this moment in time, it's still function. No need to get the values of t or whatsoever. Okay? Things like that. So if I will say also, the object moves at a function of t, 16t minus 6, x to 17. What is the position of the object at a time 4 seconds? Muna na ito kung game ninyo. Substitute 3 ang 4. So t, you will get the value of x. Okay? So the x will be your position of your object at a time 4 seconds. So meaning to say, I articulated the problem. Okay, get the point? But the problem is up to here only, huh? Okay, things like that. Actually, there's so many things you're gonna do this. Okay, it depends on what is being asked. But this is only the normal way, or in the traditional books, this approach. But in the future, during the examination or whatever, they will change this to something new. Okay, get the point? That's what matters the most there. It's your critical thinking and analysis already. Okay, you get the point? Okay, things like that. Okay, any questions so far for this? Can we give you another example also that looks like a little bit confusing? Well, a little bit confusing. Okay, you want another sample problem? Okay. Things like that. Diba? Okay. So, yun lang muna sa ating integral calculus, rectilinear motion. This is your instructor and your mathematics teacher, Sotero. Bye-bye. God bless everybody. See you later for another sample problem. Bye-bye.